What is up, everybody? It's Dan from sagemathtutoring.com, and I have another video going over some of the kinds of problems that you might have to face on the SAT. So let's crack right into it. We have Maria plans to rent a boat. The boat rental costs $60 per hour. She will also have to pay for a water safety course that costs $10. Maria wants to spend no more than $280 for the rental and the course. So the boat rental is available only for a whole number of hours, so that's important. Whole number of hours. What's the maximum number of hours for which Maria can rent the boat? Well, first of all, you can set up an inequality. So this $10 is a flat fee, and it's going to be $60 per hour. So ultimately, that's going to be $10 as a flat fee plus $60 times however many hours goes by. So we'll say that H is the amount of hours. And we need that to be no more than 280. So that means it's got to be less than or equal to 280. And then from there, you basically just kind of solve. For H, you would subtract, 10 from both sides. You'd end up with, therefore, 60H is less than or equal to 270. Dividing both sides by 60. Obviously that would cancel these, and then you'd have H has to be less than or equal to 4.5. So when it comes to this answer, remember, if the boat rental is available for only a whole number of hours, what's the maximum number of hours? Well, H has to be less than or equal to 4.5, so the largest, amount of hours that H could be is 4, okay, because it's got to be less than or equal to 4.5, so we're going to say H equals 4. Hopefully that makes sense. Moving on. Okay, the expression above is equivalent to A over x plus 2 squared, where A is a positive constant. X does not equal -2. What's the value of A? So first of all, when they say X does not equal -2, just don't freak out. That basically means, that's their way of saying, don't worry, this whole thing is not undefined. Undefined is when you have a 0 in the denominator, so we know for sure that this thing is not undefined. So what is the value of A? So what I would do is I would set up the equation based off of the information. The expression above is equivalent to this, so that means we could rewrite the whole thing, where it's 2x plus 6 all over x plus 2 squared minus 2 times x plus 2. And I could already foresee I'm going to need a little space there in a moment, but this whole thing equals A over x plus 2 squared. And the bottom line is this all equals that, but we do not have a common denominator. So we're going to want a common denominator, and in fact, we're going to want a common denominator that matches this denominator. Well, that's actually not going to be too hard. This already has the denominator we're looking for, but we need it over here. So you could get that common denominator by multiplying the bottom by x plus 2. Of course, you have to do it to the top as well. And that would give us x plus 2 squared. So then we would have that common denominator of x plus 2 squared. So let's take a look at the next line. So what I'm going to do is I'm just going to take into account that at least on the left-hand side of the equal sign, it's official. We have the denominator we're looking for. I'm going to rewrite this part as well. But it's really the numerator on the left side that I'm kind of interested in right now. Whenever you have a common denominator, you keep the denominator and then you add or subtract the numerators. In this case, we're going to subtract the numerators. So it's going to be 2x plus 6. Now it's going to be minus 2 times x plus 2. All right, I'm actually going to write that for now. You got to be super careful with subtracting because eventually we're going to be distributing a -2 into that. All right, so as a result of that, on the next line, we're going to have 2x plus 6 minus 2x minus 2. And again, you have that denominator of x plus 2 squared. And then we have x plus 2 squared down there. And at the end of the day, I feel like we could just ignore the denominators because bottom line is this has to equal that. Because basically what this is saying is something over this denominator equals something over this denominator, which is the same denominator. So the numerators must therefore be the same. Hopefully that makes sense. What I'm going to do is I'm going to simplify this side as, looks like it's 6 minus 2. I think it's just going to be 4 because these two x's cancel, right? So it's going to be 6 minus 2. So 6 minus 2 is 4, and that equals a. Okay, so focusing purely on the numerators only, 4 equals a. Hopefully that makes sense. There's always a chance I made a careless mistake, but I don't think I did. Moving on. All right, intersecting lines R, S, and T are shown below. What's the value of x? Okay, so there's something called the exterior angle theorem that basically says this angle right here is the sum of this angle and this angle. So in other words, the smiley face angle equals the star plus the little triangle. So that's an exterior angle because it's on the outside of the triangle, and that's equal to the sum of the two remote, they call these the remote angles. You could also refer to them as the, quote, far away angles because they're far away from this one. It's not this angle, but the two far away ones, okay? So the bottom line is here we have an exterior angle right here, and of course we have an opportunity right here to just call that, I believe that would be 74, right? Because we have that linear pair situation. So for my student at home watching this, I'm actually making this for kind of specifically for one particular student. For my student at home, just hopefully you understand, you know, we'll go over more geometry later, but hopefully you understand that this angle plus this angle are supplementary. That's what's called a linear pair, and linear pairs are always supplementary such that, you know, this angle plus whatever the heck this is should be 180. So if I want to find this one, it's going to be 180 minus 106. It's going to be 180 minus 106, which, unless I'm making a dumb mistake in my head, should be 74. So then you have this exterior angle that should equal this plus that. So let's take a look at that. It's going to be like x equals 74 plus 23, and that equals, what's that, 97. Okay, so again, that is how you do it. Again, there's always a chance I made a careless mistake, but as long as you understand the basic broad strokes strategy, you have an exterior angle, so it's going to be the sum of this and that, and you had that opportunity to realize that that's 74 because that's a linear pair. Okay, some values of the linear function are shown in the table above, which is the following defines f. Yeah, I always try to be really careful with the x-com. Just notice, is it going up by 1? Is it going up by 2? Is it going up by 1 and then up by 2? But the bottom line is it's going up by 2 every single time. Now, I'm also noticing that the slopes in each of these answer choices are all different. So my thought is, why don't we just find the slope of this, and then we're going to have our answer, right? Because all these slopes are different. So the slope formula, which is definitely worth familiarizing yourself with, is m equals y2 minus y1 all over x2 minus x1. I like to use empty parentheses as well and just kind of fill it in from there. So let's work with these 2 points. That's actually a point. That's literally the point 1 comma 5. And we'll work with this one. It doesn't matter which 2 you choose. You just pick 2 points. That's 5 comma 21. So we'll call this y2. We're going to call this y1. We'll call this x2. We're going to call that x1. So this is going to be 21 minus 5 up top. And it's going to be, 5, or rather, yeah, 5 minus 1 down below. And as a result of that, we are going to get 21 minus 5 is 16, and 5 minus 1 is 4. 16 over 4 is 4. So that's the slope, and therefore this must be the answer. Hopefully that makes sense. Moving on. Okay, which of the following is the equivalent form of this? All right, At first glance, it looks like the difference between two squares, because it's like something squared minus something else, but there's no exponent of 2 here, so this is not the difference between two squares. So we're going to have to approach this by like simplifying it. However, I will say one of the things I've sort of picked up from experience is that sometimes you could just choose like one of the terms to work with. For example, the constant term that, this term that doesn't have an x attached to it, this term doesn't have an x attached to it, if you could just work with these and figure out what they would become after like doing the whole shenanigans, you'll notice that all the constants here are all different, so we should be able to actually shortcut our way to the answer by sort of ignoring everything else and focusing only on what's going to happen to the terms that don't have an x attached to it. In other words, what's going to happen to the constant terms, and then whatever happens to these constant terms, you compare to these constant terms, and that's going to give you the answer. So I'm going to rewrite this right here, where it's like 1.5x minus 2.4 times itself, because that's what squaring something is. And at the end of the day, that's of course going to be, subtracting the... I'm going to get this over with right now, actually. We're going to distribute that in there, right? We're going to distribute the negative here and there. So that's going to result in negative 5.2x squared plus 6.4. So once again, I'm going to focus only on what's going on with the constants. So in this case, this would be a FOIL situation where it's like first times first, outer times outer, inner times inner, last times last. Now I could do all that and I would stumble upon the answer. But again, it's that last times last moment that is going to feature, a product that's a constant. And then I could just add it to 6.4, all right? So it's really going to be, negative 2.4 squared plus 6.4. Now, why am I saying negative 2.4 squared? Because when you do the FOIL, FOIL, we're going to write FOIL. The L stands for last, which means we're going to do negative 2.4 times negative 2.4. That's going to be the last part of the FOIL process, and that's going to give us this sort of constant term. And then we're going to add that to this 6.4 over here, and that's going to give us one of these constant terms. Okay? So again, it's taken me a while to explain it, but if you actually did it and use your calculator, it would be a lot faster than doing just everything out in the textbook fashion. Now, putting this in your calculator, you do this first, and then you add it to 6.4, and that's going to give you 12.16, which is that one. Hopefully that makes sense. Moving on. Okay, in the 1908 Olympic Games, the Olympic marathon was lengthened from 40 kilometers to approximately 42 kilometers. Okay, so that's a difference of 2 kilometers. Of the following, which is the closest to the increase? Right, the increase in 2 kilometers in the distance of the Olympic marathon in miles. 1 mile is approximately 1.6. So already we could just set up a proportion, basically, where you have miles over kilometers. In this case, it's 1 mile for every 1.6. We'll say 1 mile for every 1.6 kilometers. And set that equal to, well, certainly we're trying to kind of analyze which is closest to the increase in distance. Now we know that the increase in distance is 2 kilometers. So we're actually going to put that here because we want to find out what kind of mileage corresponds with 2 kilometers. So in this case, that's going to be X, that's going to be the unknown. Now I'm actually going to erase these little letters here because the bottom line is the numbers are all correct. Now my student at home probably knows you just cross multiply there. So 1 times 2 is obviously 2. It's going to be 2 equals 1.6x. Divide both sides by 1.6, and you would get, if you used your calculator, you would get 1 0.25. So hopefully that makes sense. Okay, the density d of an object is found by dividing the mass m of the object by its volume v, which the following equations gives the mass m in terms of d and v. So in other words, when they say which of the following equations give the mass m in terms of blah blah blah, that means solve for m. Okay, something in terms of other stuff always means solve for that something. So bottom line is, we want to get super clear about the original sort of equation that they outline here. The density d of an object is found by dividing the mass by its volume. So that could be the tricky part. It's d equals m over v. Okay? The density d is found by dividing the mass by its volume. And at the end of the day, again, we want to solve for m. All you have to do in order to make that happen is multiply both sides by v. And you will indeed get m equals d times v, because those canceled. And that should be the answer right there. Okay, a polling agency recently surveyed 1,000 adults who were selected at random from a large city and asked each of the adults, are you satisfied with the quality of the air in the city? Of those surveyed, 78% responded that they were satisfied with the quality of the air in the city based on the results of the survey. Which of the following statements must be true? Must it be true that of all adults in the city, 78%? Okay, so let's actually just, before we even dive into it, let's be clear. Let's imagine that this circle represents the city. Maybe it's New York, okay? And they literally just kind of studied 1,000 people. Now we know that there aren't 1,000 people in New York. There's a lot more than that in New York, but you know, a little piece of New York was surveyed, and they found that 78% of these people, and I'll just use this to represent the 78% of those people, said that they're satisfied with the quality of air in the city. All right, so just to be clear, that's what's happening here. We have the entire city, we have 1,000 people from the city, and 78% of those people say that they don't mind the quality of the air in the city. Roman numeral 1, must it be true that of all adults in the city, 78% are satisfied with the quality of air? Well, absolutely not. 78% of these 1,000 people that they, randomly chose, those people are satisfied. But if you surveyed more people, it's probably the case that there might be more, people who are satisfied as well. So we're going to get rid of that one. If another 1,000 adults selected at random from the city were surveyed, 78% of them would report that they are satisfied with the quality of air. So my student at home probably is recognizing that that can't be true. I mean, imagine we surveyed this 1,000 people over here. Must it be true that 78% of these people are satisfied with the air quality of the city? Absolutely not. It might be a little less, it might be a little more, it might be way less. And, there's even a chance, there's even a possibility that 0 people from this 1,000 people are satisfied. You'd like to think that it would be around 78. You'd like to think about that this 1,000 people might be representative of the whole city, but you have no way of guaranteeing that. So when they ask, must it be true? Well, no. It's possible for it not to be true. So therefore, Roman numeral 2 is gone. Roman numeral 3. If 1,000 adults selected at random from a different city were surveyed, 78% of them would report they are satisfied with it. Well, yeah, I'm not even going to draw that. Bottom line is we can see that that does not need to be true, because what if another city has way more pollution, right? Then it's probably going to be the case that less than 78% of those people would be satisfied with the air quality of the city. So that's why, thank goodness, none is an answer. Moving on. Okay, one method of calculating the approximate age in years of a tree of a particular species is to multiply the diameter of the tree in inches by the constant called the growth factor. So there's the growth factor. The table above gives the growth factors of 8 species of trees. Okay, right. right? Scatter plot above gives the tree diameter plotted against age for 26 trees. The growth factor of this species, so this is one particular species, is closest to that of which of the following species of tree. Okay, so the age is over here, the tree diameter is over there. Now, by the way, we know from this information right here that age, A, equals the growth factor times the diameter, okay? So, and funny enough, I mean, here you have a nice, quadrant 1 of an XY coordinate plane, only this is really the age axis, and this is the diameter axis, and that makes perfect sense, where we could see that this is, A equals GD. Now, G in this case is essentially going to be the slope of this sort of line that goes through here, all right? And we can, find the slope, which would be your G, and then figure out which, G over here corresponds to which species, right? So I think you get what I'm saying. So basically what you want to do is use the slope formula. Now, just as a quick reminder, y equals mx plus b is the slope-intercept form. It so happens that, the b, the y-intercept for this thing is 0, because if you had a line, it would go all the way down, and it would be, cutting through the origin there. So it makes sense that there wouldn't be anything over here. I mean, there's an invisible plus 0, but we don't really have to write that. Bottom line is we do want to find G. We want to find the slope of the line of best fit over here, okay? Now, what you could do is you could sort of estimate. I mean, it does not have to be perfect. One point could be this, where it's like, 11, 70 seems like it would be hypothetically on that line of best fit. Now, notice how you don't need to actually pinpoint one of these points here. You just have to kind of imagine a line cutting through the points, okay, obnoxiously cutting through. And it has to be a line that represents like what's happening over here, okay? Now, I didn't really draw the most beautiful straight line, but it's about true that 1170 would be on there. So we're going to use that as one of the points, 11, 70. And we're going to use another point as well. Let's say 16, 110. 16, 110. And then you just use the slope formula where it's y equals, 110 minus 70, that's y2 minus y1, all over 16 minus 11. And that would give you, let's see, 40 over 5, and that would give you 8. So we have a slope of 8. Now the closest one to 8 is clearly this one right here, so that is the answer. Okay, so if a white birch tree and a pin oak tree each now have a diameter of 1 foot, which of the following will be closest to the difference in inches of their diameters 10 years from now? Right, so let's see. I'm just going to get rid of some of this stuff for now. Okay, I think it's going to be a good idea to remind ourselves that age equals the growth factor times the diameter, which I kind of just erased. But I'll make it nicer looking at the very least. So let's say that we track the age, the growth factor, and the diameter now, and then compare it to the age, the growth factor, and the diameter in 10 years. So we're dealing with pin oak tree and white birch tree. So do a little W for white birch tree and P for pin oak tree. Okay, so make a little table here. So I'm going to once again track the growth factor, the diameter, and the age. And that would be now. And let's kind of figure out what all that is. So growth factor of the white birch tree is 5. The growth factor of the pin oak tree is 3. The diameters are 1 foot currently. So that's going to be, we could call it 1 foot, but they say 1 foot equals 12 inches, so that makes me think we should think in terms of inches. We want to be pretty careful with that because they actually ask for inches anyway, so let's get that unit down. So we have 12 inches, right, because the diameters are the same. And seeing as how age equals the growth factor times the diameter, we would just multiply these two to get the age now of the white birch tree. 5 times 12 is 60, 3 times 12 is 36. But then there's the phenomenon of 10 years later, okay? And we're going to kind of track what happened there, all right? And to do so, we will once again take into account growth factor, diameter, and age. Well, the age might be the easy part because it's 10 years later, so it's going to be 60 plus 10, which is, of course, 70. And over here it's going to be 36 plus 10, which is 46. Now, the growth factor has not changed. The growth factor should remain the same, so that's still going to be 5 and 3. And at the end of the day, we want to find, well, what's the diameter? What's the diameter? Because that's what they're asking, right? They're like, what will be closest to the difference of their diameters? Let's find their diameters now. Okay? We're going to find the diameters now. So the diameter here, notice how the diameter is really what you get when you divide both sides by g. All right. So hopefully that is something that makes sense. All I did was divide this by g and this by g, and you end up with d equals age divided by growth factor. So if you ever want to find the diameter, you just take the age and divide it by the growth factor. So to get this denominator, or this diameter, we're going to take 70 and divide it by 5. And when you do that, 70 divided by 5 is 14. And similarly, to find this diameter, we're going to take the age and divide it by 3. And when you do that, you get 15.3. And they ultimately want the difference in inches of their diameters. Well, that's 14 inches. That's 15.3 inches. And the difference between those two is clearly 1.3 inches, obviously. 15.3 minus 14 is 1.3. So that's that one. In triangle ABC above, what's the length of AD? Okay, AD is right here. So I'm already seeing that you're dealing with a 30, 60, 90 triangle. So here is a famous right triangle where that's 30 degrees, that's 60 degrees, and this is going to be something, we'll call it x. The hypotenuse is always going to be 2x, and this is always going to be x times radical 3. And you do not have to memorize this because that's in the beginning reference part of the section, okay? So that should be there waiting for you. But quickly, the side, the short leg that's across from the 30-degree angle is always some number. The hypotenuse is always going to be twice whatever that number is. And this sort of longer leg of the 30, 60, 90 triangle is going to be that number times root 3, okay? Now, we have 60 here. We have 90 here, which means that that's 30, okay? We also have a 90 over here because it's a linear pair, all right? ADB is a linear pair with CDB. Linear pairs are supplementary, therefore 90 plus this must equal 180, so therefore this is 90 as well. Okay, now that makes this 60 degrees. So it's 30, 60, 90. And in case my student at home is wondering how I know that, my student might recall that the sum of the interior angles, when you add this angle plus this angle plus this angle within a triangle, that should all equal 180. Okay, so this is 60. 60 degrees right there. Okay, what's the length of AD? Ultimately, we want to find that one, right? Well, one way of also looking at this whole triangle is that this is an equilateral triangle. And an equilateral triangle is this triangle where you have 60 degrees here, 60 degrees here, and 60 degrees here. And also, by the way, this side is the same length as that, which is the same length as that one. So all the side lengths are the same as well. Now, how do I know that this is an equilateral? Well, I know because we've already sort of proved that that's 60 and that's 60. So if that's 60 and that's 60, well, this big guy up here also has to be 60. All right. And if you know that you have 60, 60, 60, that's an equilateral triangle. And if you know that it's an equilateral triangle, then the side lengths are the same. So that means that this entire side length right here is 12, and this is also 12. Okay. So the question is, what is this right here? That's the ultimate goal, right? To find out what that is. Now, I happen to know that this is going to be 6, and the reason is because of the converse of the perpendicular bisector theorem. Okay, I know that that's kind of crazy, but so basically, let's just put it this way. If you have two, segments here that are equal to each other, and you drop another segment straight down in such a way that it intersects at 90 degrees, that will be a perpendicular bisector. This green line will be a perpendicular bisector. Now that's two words: perpendicular because it forms 90 degrees, bisector because it splits this segment, this bottom segment, it splits that in half. So this side, this little segment here is going to be equal to that little segment there. That's the converse of the perpendicular bisector theorem. Once again, if this side is the same as that side, and if you drop a segment straight down in such a way that it forms 90 degrees with the base, then not only is it intersecting the base in a perpendicular fashion, but it's also bisecting the base. Okay? Now, let's contrast that to another situation where, let's say this is the same as that, but you have this segment that goes like that. Well, that wouldn't bisect. Like, this is not equal to that because this is not perpendicular. This is not 90 degrees. But had you dropped it down in such a way that would form 90 degrees, then that would indeed bisect this base right here, which means that this segment is the same length as that segment. So this base right here is being bisected by this perpendicular bisector, so therefore this must be half of 12, which is 6. Moving on. Okay, the figure on the left above shows a wheel with a mark on its rim. Well, okay. Wheel is rolling on the ground at a constant rate along a level straight path from a starting point to an ending point. The graph of y equals d of t on the right could represent which of the following as a function of time. Well, as it goes by, I mean, it's the dot is going up and down, right? Like as time goes by, the height of the dot is going up and down, right? So to me already, just without even looking at these, as time goes by, the height of the dot starts here, and then it goes down here, then it goes up here, then it goes down here, then it goes up there, right? So the graph of y equals d of t, don't get thrown off by that. That just means this graph, okay? This graph could represent which of the following as a function of time when the wheel begins to roll. Speed at which the wheel is rolling, no. Distance of the wheel from its starting point. Yeah, it doesn't make sense because that would just be a straight line up, because as time goes by, we get further from its starting point. There wouldn't be this squiggling action. It's not like it's going back and forth, right, to its starting. It's not like it goes back and forth to its starting point. The distance of the mark on the rim from the center of the wheel. No, because if you went down, that means that there would be a distance of 0 from the mark to the center of the wheel, and there's no moment where this dot, this mark, is going to hit the center of the wheel, right? If you go down and it's 0, you know, y equals 0 in this case, that means that the mark hits the center of the wheel, so that's gone. Doesn't make any sense. So yeah, D. It's my original guess, the distance of the mark on the rim from the ground. Moving on. Okay, in the equation above, if A is negative, okay, and B is positive, which of the following must be true? Okay, so I'm going to rewrite this. So we have A minus B all over A equals C. Now, at the end of the day, we know for a fact that A is negative. So we're just going to sort of temporarily represent that fact right now by putting a little green negative in front of it, just to remind ourselves A is negative, this A is negative. And one thing you could do when you have a single term down below is you could split this, where it ends up becoming negative A over negative A minus B over negative A, and that equals C. Okay? Now, this is just 1. Okay? And we're subtracting a negative fraction because B is definitely positive because they literally said that. So it's a positive over a negative. So this is a negative fraction. So when you subtract a negative fraction, it's really the same thing as adding the fraction. And then we end up with C. So we can draw conclusions about C right now, which is what we want to do. First of all, we know that C is going to be positive because it's a positive number plus a positive number, so that's going to be positive. We also know that C is a result of 1 plus something. So C has to be a positive number that's greater than 1. So it's not that, it's not that, it's not that. It is A. Boom. Hope you like that. It's pretty smart. If I do say so myself. All right, in State X, Mr. Camp's 8th grade class, consisting of 26 students, was surveyed. Okay, so he's got 26 students. Surveyed the 8th grade class of 26 students. 34.6% of the students reported that they had at least 2 siblings. So already, it's a good idea when you're dealing with these percentage type problems to, I mean, it's 26 students, right? 34.6% it looks like has at least 2 siblings. So we could say 2 or more siblings. Now, it's pretty much always going to be a good idea to get clear about what the other percentage is. Subtract this from 100, and that would be 65.4%, because there's a strong likelihood that that's going to come into play. So 65.4% must have less than 2 siblings. Less than 2 siblings. Now, even though I haven't even read the problem yet, I'm still just in the habit of doing that because it often will come in handy to have this percentage, okay? So the average 8th grade class size in the state is 26, okay? If the students in Mr. Camp's class are representative of students in the state's 8th grade classes, and there are 1,800 8th grade classes in the state, which of the following best estimates the number of 8th grade students in the state who have fewer than 2 siblings? So, once again, like I said, that other percentage might come into play. That's less than 2 siblings. So, it's going to be 65.4% of the 26 students, but there's 1,800 of those classes. Right? So if we do 65.4% of 26 and then multiply that times 1,800, then we're going to get a best estimate of the number of total 8th grade students in the state who have fewer than 2 siblings. So to do that, you could, we want to multiply 65.4% times 26, but we're going to want to move this decimal place over twice, right? So that's how you convert a percentage to a decimal. So we have 0.654 times 26. That's going to give you 17.004. And then we're going to want to multiply that times 1,800. Okay? So it's going to be that times 1,800. And in the calculator, you could do that. That's going to be 30,600. 30,600 approximately. Hopefully that makes sense. Moving on. Okay, the Townsend Realty Group invested in 5 different properties listed in the table above. The table shows the amount in dollars the company paid for each property and the corresponding monthly rental price in dollars the company charges for the property at each of the 5 locations. Okay, the relationship between the monthly rental price R in dollars, that's this, and the property's purchase price in thousands of dollars can be represented by a linear function. Which of the following functions represents the relationship? Okay, so when it comes to this one, you guys are probably used to, the whole y equals mx plus b stuff. All right, where that's the slope and that's the y-intercept. Okay, so bottom line is all the slopes here are different, which means that if we could just find the slope of all this, then we'll have the answer. Okay, so we want to find the relationship between the monthly rental price R in dollars and the property's purchase price in thousands of dollars. All right, so since it's the property's purchase price in thousands of dollars, that means we can disregard these 3 zeros when we're formulating the equation. Okay? Now all we need, again, is to simply find the slope, which means we just need 2 points. Let's choose the first row, and we're going to choose the second row. Now the points are going to be, as you can see, it's like, this is P in thousands of dollars. So this 128 is going to be the sort of X coordinate, and this is the rental price. So that's over here. So that's going to be like the Y coordinate. So the X coordinate is P. The Y coordinate corresponding with R of P is rental. So the first point from the first row is literally going to be 128, 950. And the next point in the second row is going to be 176, 1310. And then all you have to do is just break out the slope formula to find the slope between these and that is this. So we're going to say m equals, I always like to do these empty parentheses. So the slope equals, we'll call that y2 and x2. We'll call that x1 and y1. So it's going to be 1310 minus 950 all over 176 minus 128. And that's going to give you, let's see, what would that give you? Shrink this down a little bit. That is going to give you m equals, if you were to work all that out, it would turn out to be 7.5. And there's only one answer that has 7.5, and that's D. Okay? So all you had to do is pick 2 points, find the slope, realize that the so-called x-coordinate is the purchase price, the so-called y-coordinate is the rental price. And the real giveaway with that is this R that's over here. That's rental price. Okay. So anyway, we found the slope using the slope formula, and there was, each slope was unique here, so we could kind of hone in on what the correct slope was. All right, let's remove all this and look at problem number 24. Okay, so Townsend Realty purchased the Glenview Street property and received a 40% discount off the original price along with an additional 20% off the discounted price. Right, so what they're saying is that this price right here of Glenview is after that discount. Okay, so there was some original price where it was larger than 140,000, and then they took 40% off of that, and then there was 20% off of that, and then you ended up with 140,000. So what you could do here is you could represent the original price as X, and if you did a 40% discount off of X, that means that what you're really doing is paying 60% of X. Okay? So when you apply a 40% discount, it's the same as multiplying X times 0.6, because 60% could be converted to a decimal, and that decimal will be 0.6. And hopefully that makes sense. If I have, I don't know, if I'm about to buy a shirt that's $100, but there's a 40% discount, well, I'm only going to pay $60 for that shirt. In other words, I'm going to pay 60% of the original price. So that's what we're doing. We have an original price that we don't know what it is yet. In fact, that's our answer. We're trying to find out what the original price was. We know that it had a 40% discount, and therefore, in a certain moment in time, we had 60% of the original price. But then there was 20% of that, where that's going to be, for the exact same reason, we're going to be left with 0.8 or 80% of this. Now you can think of, maybe this being wrapped up in parentheses or something, or brackets or something, where it's 80% of this, But the bottom line is, this is just multiplication. At the end of the day, it's really just a string of numbers being multiplied together. So we don't really even need the brackets. All right, we don't even really need those. Okay, but at the end of the day, after doing all this discounting shenanigans, that's going to equal the purchase price, which is 140,000. Okay, and then at this point, it's just a matter of really solving for X right now, and we could do that by dividing everything by 0.6 times 0.8, 0.6 times 0.8. That would cancel, 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 cancel. We'd left with x equals. And if you used your calculator for that, you would get 291,666. So that, of course, rounds up to B. Moving on. Okay, psychologists set up an experiment to study the tendency of a person to select the first item when presented with a series of items. In the experiment, 300 people were presented with a set of 5 pictures arranged in random order. Okay, so we want to see the tendency of a person to select the first item when presented with these 5 pictures. Each person was asked to choose, so there were 300 people. Each person was asked to choose the most appealing picture. Of the first 150 participants, 36 chose the first picture. Among the remaining 150 participants, P people chose the first picture in the set. If more than 20% of all participants chose the first picture in the set, which of the following inequalities best describes the possible values of P? So obviously this looks like a very confusing bunch of inequality equation type things, but let's get a sense of what's going on. We have 300 total people, which is split into 2 separate groups of 150. And when it comes to the first 150, 36 chose the first picture in the set. And when it comes to the other 150, P chose the first picture in the set. And what we're told is that more than 20% of all participants chose the first picture in the set. So therefore 36 plus this has to be equal, or has to be more, I should say, than 20% of 300. Well, what is 20% of 300? 20% of 300 is 0.2 times 300. And whatever that would be, I guess that's, what, 60? Okay. So either way, this is the answer, because it's going to be P plus 36 has to be greater than 0.2 times 300. P plus 36 has to be greater than 20% of 300. And they're just kind of saying, oh, by the way, P has to be less than or equal to 150, which makes total sense because P is a subset of this 150, so P has to be less than or equal to 150. Hopefully that makes sense. Okay, the surface area of a cube is 6 times a over 4 squared, where a is a positive constant. Which of the following gives the perimeter of one face of the cube? Okay, well, my thought is, first of all, here's a cube. Okay, and as you may know from rolling die, there are 6 faces to a cube. And the surface area is what happens when you take the area of this thing and you add it to the area of this one, and then you add it to the area of this one. Now it so happens that the area of this face should be equal to the area of all the other faces because it's a cube. The side lengths are all the same all the way around. So you're going to end up with the same area on each face. So really you could think of the surface area, I'll call it SA, of a cube, I'll put a little C down there, is always going to be 6 times the area of one face. Okay? Because, again, the area of this face is the same as the area of all the other faces, and if I want the total surface area all the way around this thing, you just take the area of one face and you multiply it by 6. Alright? Now we already kind of see that that's what's happening here. We have 6 times, the area of one face. It's 6 times this, but we can kind of use logic to know with certainty that this inside the green brackets is the area of one face. Well, how do you get the area of one face? You multiply the side times the side, and that would give you, this area. It would be side squared at the end of the day. So the area of one face is side squared. Well, if you look here, you could very easily see that this must be the side then, because it's side squared. So the surface area of a cube is 6 times the area of one face. Well, this is the 6 times the area of one face, and the area of one face is side squared, so therefore a over 4 must be the side. So side must be a over 4. Now we want the perimeter of one face. Well, we know that the sides are a over 4, so I'm actually going to write that in there. I'm going to write a over 4 and a over 4 here. But we know that the perimeter of the one face is sort of the length of the square all the way around. So it's going to benefit us to recognize that that side is a over 4 and that side is a over 4. And we can really clearly see it's just going to be a over 4 plus a over 4 plus a over 4 plus a over 4. We could also think of it as 4 times a over 4. And the 4's cancel. And that leaves you with just a, which should be the answer. The graph of the linear function f is shown in the xy plane above. The slope of the graph of the linear function g is 4 times the slope of the graph of f. So, okay, we got this slope here, but g has a slope that's 4 times this slope, so g is clearly, more slanted. If the graph of g passes through the point 0, negative 4, what's the value of g of 9? All right. Well, it'd be nice to know, if we want g of 9, like imagine g of x, the equation was x plus 2, right? It's not, but imagine it was. Well, when they ask for g of 9, that would be easy. It would be like, okay, g of 9 equals 9 plus 2, because that's what you do with this function notation. You plug in 9 over there, and that would equal 11, okay? So basically what I'm illustrating here is if we just had g of x, if we actually had the equation, then we'd be able to find out what g of 9 is. So our first goal is to find the equation of g of x. All right, we're going to find the equation of g of x. And the way that we're going to find the equation of g of x is by using the clues that they already sort of gave us. First clue is that the slope of g of x, the slope of g, is 4 times the slope of this thing. So what is the slope of this thing? It looks like it's up 2 over 1, 2, 3, 4. Yeah, that looks about accurate. So it's up 1 over 2. This part doesn't look terribly accurate, but it looks like it's up 1 over 2. So that's a rise over run of 1/2, right? So the slope m of this line is 1/2, but we know that the slope of the other line g is 4 times that. So 4 times 1/2 equals 2. So we know for sure that, g, the line g, really has a equation that says y equals 2x plus b, where b would be the y-intercept. Now, we could kind of plug in 0 for x and negative 4 for y to find b, but the bottom line is, anytime you have an x-coordinate of 0, like that is sort of showing you the y-intercept. The y-intercept is negative 4 because, if our line g passes through that point, well, that point's here, right? That point's here, 0, negative 4. Well, that's the y-intercept, right? Negative 4 is the y-intercept. So I'm going to rewrite this equation only with the y-intercept. And at the end of the day, I'm using y to get it to look sort of like that, y equals mx plus b form, okay? Because most students are kind of familiar with that. They're a little less familiar with the function notation, but let's keep it in mind that this is really g of x. This is g of x equals 2x minus 4. So we have succeeded by using the fact that the slope of g of x is twice the slope of this, and by utilizing the fact that the y-intercept is negative 4 because they give us this point, we know the equation of g of x. Now, in order to find g of 9, all we have to do is plug 9 in. So g of 9 equals 2 times 9 minus 4. That's going to be 18 minus 4, and that's going to be 14. All right, x squared plus 20x plus y squared plus blah, blah, blah. All right, the equation above defines a circle in the x, y plane. What are the coordinates of the center of the circle? Okay, so to be clear, the equation for any circle looks like the following. It looks like x minus h squared plus y minus k squared, and that equals r squared, where hk is the center and r is the radius. So that right there is worth being familiar with for sure. So the bottom line is, if we could get this to look like that, then we would know what h is and we would know what k is, and that's the center. Notice how we're not concerning ourselves with the radius here. We're really just concerning ourselves with the center. So of course the question is, how are you going to get that to look like that? Well, unfortunately you're going to have to complete the square, which is a skill that my student, I don't know how much time my student has spent on that, but we're going to do it right now. So we have x squared. Now, first of all, it's actually good to write a little space between the x terms and the y. And you're going to see why in a moment. So how do you complete the square? So first of all, I wrote this in a weird way where there's this space. But just remember, it's, you know, there should really be a plus here. Just remember, this just the same thing as that. It's just I put a little space there, okay? So what you have to do to complete the square is you take a look at, like, for example, these x terms here. And you just kind of have to go with this. If you're new to this information, don't worry about why I'm doing any of this stuff. Just kind of go with it, all right? This is a technique that really is helpful. So what we're going to do is we're going to take that 20 and divide it by 2. And that gives us 10, right? 20 divided by 2 equals 10, okay? So you always take this term that has the single x with it, you divide it by 2, the coefficient by 2, and then you square the result. So we have 10, so now we're going to square the result, okay? And as a result of that, it becomes x squared. As a result of that, it becomes x squared plus 100. Now, I'm not allowed to add 100 over here without adding it on the other side of the equal sign, because you're not allowed to just make up stuff, you know? You're not allowed to just, you know, bring new numbers in without balancing things out. So we're going to be making sure that we add 100 over here. Now, as you might suspect, we're going to do something similar over here. We're going to divide 16 in half, which is 8, and then we're going to square that. Now, 8 squared is 64. I'm not going to write that, you know, the calculation. I'm just going to go ahead and write plus 64. Now, this becomes plus 64. All right. So then you take this trinomial here and you factor it, and that's going to be always x and whatever this was divided by 2. So it's going to be x plus 10 squared. Now just take it on faith for now. Over here, it's going to be the same deal. And it's going to be y and whatever this was divided by 2. Okay? And then we end up with all this stuff here. All right, let's work this out. We actually don't have to, but we're going to work it out. That's going to be 124. So now it's official. We have an equation that at least somewhat resembles that previously mentioned equation of a circle. Notice how the center, once again, as I had stated earlier, the center is HK. Let's kind of analyze this real quick. What is H? H is the number that's currently being subtracted from X. What is K? K is the number currently being subtracted from Y. So if we want to find H over here, we have to ask ourselves, what's currently being subtracted from X right now? A negative 10 is being currently subtracted from X right now. Think about it. X minus negative 10, that would give you X plus 10 squared. So this X plus 10 means that we're subtracting a negative 10. Therefore, the H, or we could say the X coordinate of the circle, is negative 10. And it's going to be negative 10 comma whatever the Y coordinate is. Now we could find the Y coordinate. It happens to be negative 8. Or we could just stop there, because if the X coordinate of the center of the circle is negative 10, well, we're done. That's the only answer that has that. So hopefully that makes sense. Now, obviously completing the square is something that requires practice to really get the hang of. For those of you watching the video, just feel free to rewind it if need be. Follow the steps, memorize the steps, watch a Khan Academy video about completing the square if need be. But that's how you do it. In the equation above, A is a positive constant, and the graph of the equation in the xy plane is a parabola. Which of the following is an equivalent form of the equation? Okay. Tempted to say B. Well, these are all answers that if you FOILed them, you'd be able to, see which one would work. So let me just review FOIL real quick. Imagine you were dealing with x plus 3 times x minus 7. Now this is a separate problem, but I'm using this to illustrate the concept of FOIL. FOIL says multiply, F means multiply the first times the first, so that's going to be x squared. The O means multiply the outer times the outer, so that's going to be negative 7x. The I means inner times inner, so that's these two, so that's going to be plus 3x. And then finally the last means 3 times negative 7, so that's going to be negative 21. And that's how you FOIL. Now, often you're going to want to combine these two middle ones. So it's going to be x squared minus 4x minus 21. Okay. And when it comes to this one, if you FOILed these, notice how the L for last, it would be a times negative a, and that would give you a negative a squared. That's not what we have here. If you multiply this last times this last, that would be the square root of a squared, which would actually give us an a, because this exponent of 2 would cancel that square root symbol, leaving us with just a. So that means b is a contender. If you multiplied a over 2 times negative a over 2, what you would have is negative a squared over 4. Clearly that's not what we have over here. And this one here might be helpful to just write it out as x plus a times x plus a. And the L for last means that when we do a times a, that's going to be a squared, and that's not what we have here. So the only one that works is B. Hopefully that makes sense. The painting The Starry Night by Vincent van Gogh is a rectangular in shape with height 29 and 36.25. if a reproduction was made where each dimension is 1/3 the corresponding original dimension, what's the height of the reproduction in inches? Well, the height of the reproduction is going to be 1/3 of this one, right? That's the height of the real thing. We're curious about the height of the reproduction. Apparently, the reproduction is such that each dimension is 1/3 the corresponding original dimension. So the height of the reproduction is going to be 1/3 of 29. It's pretty easy, actually, as long as you don't get lost in, like, the words. So it's 1/3 of 29. Now, the real secret of the universe is that 1/3 of anything is just that thing divided by 3. In the same way that 1/2 of something is that something divided by 2. Or you could just remember that there's an invisible 1 underneath there, and we're just multiplying straight across. So we're going to end up with 29 over 3. Now, this is a grid-in response question. You could totally write 29/3, and then you'd be done. Now, if you want to use your calculator, you could do 29 divided by 3, get whatever that decimal is, and then put that into the grid-in. All right, so that's the answer to that one. On PS above, PQ equals RS. I'm just going to draw a little tick mark there, right there, and right there. What's the length of PS? So in other words, what's the length of the whole thing? Well, obviously the length of the whole thing is x minus 1 plus x plus 3x minus 1. I'll just write that. X minus 1 plus x plus 3x minus 7, I should have said before. That's literally the answer, except it'd be nice to know what x was. And then we would just substitute it in, figure out the answer. Well, the good news is we have enough information to figure out what x is, because they said that PQ is equal to RS. This is equal to that. Therefore, we can set up a separate equation that says x minus 1 equals 3x minus 7. I'm going to subtract x from both sides, giving me 2x. I'm going to add 7 to both sides, giving me 6. I'm going to divide both sides by 2, giving me x equals 3. So that's what x is. So therefore, it's really going to be 3 minus 1 plus 3 times 3 minus 7. Now, PEMDAS would have us multiply that first, so whatever, I'll just do that. It's going to be 9 minus 7. Let's get this over with. 3 minus 1 is 2, plus 3 is 5. Let's just kind of piece this together. And then finally, 5 plus 9 is 14, minus 7 is 7. Unless I made a careless mistake, that's definitely the answer. Moving on. Okay, in the xy plane, the point 2, 5 lies on the graph of the function f. If f of x is that, where k is a constant, what's the value of k? Well, they're baiting you into getting confused by like, oh, what is this? I'm not used to these. With the exponent of 2, and do I need to know how to graph it? Whatever. The answer is you don't need to know that much about this. I mean, I know because I have experience that, you know, that could really be rewritten as negative x squared plus k, and it's really just, you know, some parabola that goes down, right? And maybe that's k right there, you know. I know all that, but k could be negative too, by the way. But I know that it's a parabola, yada, yada, yada. But the thing is you don't even need to know that. The bottom line is this is a graph of some curve or line or whatever, some graph, right? And this point is on the graph. So I know it's written like f of x equals k minus x squared. But hopefully you guys at home watching know that this could be rewritten as y equals k minus x squared. It's sometimes helpful to just remember that the f of x terminology or symbology is sort of synonymous with this y stuff as well. Now, why did I rewrite it like that? I rewrote it like that to remind us that we could always plug 2 in for x and 5 in for y. Okay? and that would help us find k. So that's going to be 5 equals k minus what squared? 2 squared. And 5 minus equals k minus 4, therefore, and k equals 9. That should be the answer, unless I made a careless mistake, which I do not think I did. Moving on. A landscaper is designing a rectangular garden. The length of the garden is to be 5 feet longer than the width. Right. If the area of the garden will be 104... Oh, come on. Too easy. Rectangular garden. There it is. The length is 5 feet longer. That's the length. That's the width, right? So the length is 5 feet longer than the width. So bottom line is the length equals the width plus 5, right? In fact, I'm going to write W plus 5 up here just to kind of represent the length as purely W plus 5 up here. And then we have that width of W. We already know the area is 104. We want to know what the length is. Well, it'd be nice to know what W is. I mean, if we knew what W was, then we would just add 5 to it, and then we'd have the length, right? So why don't we go on a mission to find out what W is. And the way that you could do it is realize that area equals length times width. Well, we already know the area of this thing. It's 104. So it's going to be 104 times the length, only this time we're going to write W plus 5 because we only want to work with one variable, times the width. Okay? And then we could distribute that W there and there. So that's going to be 104 equals W squared plus 5W. We're going to subtract 104 from both sides. W squared plus 5W minus 104. And at that point, we should probably be able to factor that. So 0 equals W. So the question is, what are some factors of negative 104 such that when I add them, I get 5? In other words, what two numbers multiply to negative 104 but add up to positive 5? That's a tough one. I don't know off the top of my head. Maybe you guys do. But what I'm going to do is just do this little factor thing. So 1 times 104, clearly that's not it. 2 times 52, clearly that's not it. 3 does not go into it. Does 4 go into it? Yes, 4 times, let's see, 20 something. 26. Does 5 go into it? No. Does 6 go into it? No, because 3 doesn't go into it. Does 7 go into it? No. I don't think so. No, it doesn't. Does 8 go into it? That's a good question. Yes, it does. 8 times 1, 3. Yes, ding, 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 ding. There is a difference of 5 between these. And I do know that since it's a negative 104, one of these has to be positive, the other one has to be negative. In this case, we want a positive 5, so the larger number is going to be positive. So it's going to be plus 13 minus 5. And therefore, W equals negative 13 or 5. That's what W is, at least. Now, we could disregard the negative 13 because it makes no sense to have a negative width. So we know with certainty that the width of this thing is 5. So if the width is 5, then the length is going to be 5 plus 5, also known as 10. That's the answer because, remember, they're asking for the length. Moving on. Point P is the center of the circle in the figure above. What is the value of x? 20 degrees, 20 degrees. All right, so here's the deal. When it comes to these circle problems, a lot of the time, it's going to rely on your ability to recognize that the radius here is the same as the radius here. And also the radius here is the same length as the radius from there to there if you were to draw it. So we are going to draw it, actually. So let's focus on this bottom triangle. And that side is going to be equal to that side. All right, because that's a radius and that's a radius, and the radius is the same length. Now, that tells me that this is an isosceles triangle, which means that this base angle has to equal that base angle. Okay. Now, all of that information also applies to this one here, okay, because this radius is clearly equal to that radius, right? And this is an isosceles triangle, therefore, so that's got to be 20 also. So what I'm going to do is kind of blow this up a little bit. So this is 20 degrees as well. Let's focus on this bottom shaded triangle. If that's 20 degrees and that's 20 degrees, then this has to be 140 degrees. Similarly, that's got to be 140 degrees. All right. Now, if that's 140 and that's 140, well, this x, when you add it all up, it should be 360 degrees all the way around. So that's going to be 140 plus 140 plus x equals 360. 140 plus 140 is 280 plus x equals 360. Subtracting 280 from both sides gives me x equals 80. So you might be wondering, how did I know to do all that? Well, let's kind of go back to the beginning. Unfortunately, with math, there is something to be said about the fact that, you know, insights and the path to victory sometimes will just flash in your mind, you know. And case can be made that it's not really fair, because it's not like you can control whether or not it flashes in your mind. But what I can say is that, remembering the general rule of thumb with circle problems, that this radius equals that radius. So to me, here's what my mind did in a flash. I immediately saw that this has to be equal to that because they're both radii. I also saw the opportunity to draw that. I didn't know if it would be useful to draw that, but I knew that we could draw it, and I knew that that green segment would be the same length as the red segment because it's the radius. And then I asked myself, will that be useful information? And then I saw this 20. I saw that this is a triangle. And I'm like, okay, that's the same side length as that of the triangle, so that's isosceles, which means that that's got to be 20, which would enable me to figure out what this is. I could do the exact same thing up here, and then I could do the 360 thing all the way around. So again, partly that could be due to experience, etc. But I think it's always about that first domino that then leads you into this path of, you know, mathematical associations that eventually allows you to stumble upon the eureka moment of the path to victory. You know, I just imagine this radius without even knowing whether or not doing so would be helpful, and it just turned out to be helpful. Okay, so moving on. Okay, Miss Simon drives a car from her home to her workplace every work day morning. The table above shows the distance in miles and our average driving speed in miles per hour. There's no traffic. Okay, so let's just look at this real quick. Segment of the drive, distance in miles, average driving speed. From home to the freeway entrance, from the freeway entrance to the freeway exits, from the freeway exit to the workplace. Okay. One morning, Miss Simon drove directly from her home to her workplace in 24 minutes. What was her average speed in miles per hour? So it's worth just mentioning that average speed in general, average speed formula, is the total distance over the total time. That's worth memorizing for the SAT. And total distance is what you get when you add all that up. So when you add all that up, that's going to be 17.4. Over the total time. Now they give us 24 minutes as the quote total time, but we're looking for the average speed in miles per hour. So we need to have 24 in terms of hours. In other words, how many hours is 24 minutes? Well, for every one, we'll put hours over minutes, okay? So for every 1 hour, there are 60 minutes, and we're going to set that proportion equal to x over 24. Hours over minutes, 1 hour for every 60 minutes, and we're going to set that proportion equal to our mystery amount of hours over 24 minutes. Cross multiplying would give us 24 equals 60x. Dividing both sides by 60 would give us 0.4. So the total time is 0.4 hours. So that is the fraction that's going to give us the answer. So let's just use the calculator to find out what 17.4 divided by 0.4 is. That turns out to be 43.5, which should be the answer to that one. Hopefully that makes sense. Let's look at this other stuff. So Miss Simon starts to drive at 6:30 a.m. She can drive at an average speed with no traffic delay for each segment of the drive. If she starts her drive at 7 a.m., travel time from the freeway entrance to the freeway exit increases by 33% due to slower traffic, but the travel time for each of the other two segments does not change. Based on the table, how many more minutes does Miss Simon take to arrive at her workplace if she starts her drive at 7 a.m. than if she starts at 6:30? So the section of the trip that we're really concerned with is the travel time from the freeway entrance to the freeway exit. So that's right here. This is the only thing that's really going to change if she starts her drive at 7 a.m. All right. Everything else is going to be the same. So the final question, they're like, how many more minutes does Miss Simon take to arrive at her workplace if she starts her drive at 7 a.m. than if she starts her drive at 6:30 a.m.? And it is in minutes. So we're going to have to compare how many minutes this takes under normal circumstances when she starts her drive at 6:30, and we're going to compare this situation when she starts her drive at 7 a.m. All right. Now, one thing that's also good to know. Now, I had talked about average speed equals total distance over total time. Now, that's definitely true. Now, some people I have seen in the past, people use a triangle where you'd have distance here, you'd have speed here, and time here. And for example, if you're looking for speed, well, you would cover this up and just be like, this equals distance over time. If you're looking for the time, you would maybe cover this up and be like, t, time equals distance over speed. And by the way, if you're looking for distance, you would set that equal to speed times time. Okay. So it's kind of a nice geometric way of looking at it. Nonetheless, what we have to do is find the total time it takes for her to do the normal circumstance. And as we know, that's going to be t equals distance over speed. So that's going to be t equals, and it looks like it's 15.4 over 50. And that if you plug into your calculator, is going to turn out to be 0.1016. Now that's in hours, to be clear, because this has to do with miles per hour. That has to do with miles. So this time is in hours. We're going to worry about converting it to minutes, later. But for now, we want to find out how many more minutes does Miss Simon take. Well, apparently there's a 33% increase in travel time, right? So all we got to do is find out what 33% of that is, because that's the increase, right? This is the time it takes under normal circumstances, but when she leaves the house at 7 a.m., it's going to be this plus 33% of this, right? So that difference is 33% difference. So all we have to do is find 33% of that. Now, let's do that off to the side. So 33% is something that you could change to 0.33 because of the decimal version of percentages, in case that's not clear. If you want to convert a percentage to a decimal, you just move the decimal place over twice, and you would end up with that. So it's going to be 33% of that number. And we do need to keep in mind that that's in hours, so we're going to have to multiply that by 60 minutes. And in case that's not clear, I mean, the bottom line is, imagine you wanted to know how many minutes 5 hours are. Well, you would do 5 times 60. And you would realize, oh, it's 300 minutes, right? So that's a principle to keep in mind as well. The bottom line is, what we're about to do over here is we're about to get 33% of this in hours, so that's going to give you a certain amount of hours, some weird decimal, in fact. But it's hours, and then it's going to be that times 60 minutes, and that's going to give you the amount of minutes for the same reason, that last simpler example worked. That in your calculator is going to give you approximately 6.09. And 6.09 rounds down, because they want it to the nearest minute, so that rounds down to 6. So I hope that makes sense. Kind of a long video. A lot of times these videos end up taking longer than I think they're going to. But I hope it was helpful for my student who's watching, and for any other students who are watching. I hope this was very helpful to you. And this is most definitely the kinds of math problems that you're going to find in the SAT, and to get familiar with them before the fact, obviously, is going to be hugely helpful. The SAT is interesting. They have it's kind of like a certain subspecies of problem. Like, there is overlap, obviously, with what you've learned before. However, nonetheless, there's still kind of like some patterns that pop up over time. So the more you could actually practice, like real practice tests from the big like blue book or whatever, the more prepared you'll be. All right, so anyway, I will see you next time.